what are the zeros and the respective multiplicities of f of x equals negative x times x plus 5 squared times x plus 2 squared times x minus 3. All right, so this looks like a pretty long polynomial, right? First thing we want to do is we want to make sure that we keep track of each unique factor, right? So we have the x, we have an x plus 5, we have an x plus 2, and we have an x minus 3. Now you notice that if we actually write everything out, right? For example, this x plus 5, the square tells us that there's actually two of them, right? This x plus 2, also because of the square, tells us that there are two of those. And of course the x minus 3. So let's take a look, right? If I ask you what is the degree of this polynomial, right? What is the degree of this polynomial? Well, we just have to count them up, right? So the degree of this polynomial is equal to, let's see, 1, 2, 3, 4, 5, 6. Okay? Because there are 6 factors in total. But you notice, when you look at the original polynomial, right, you kind of probably going to count, right? 1, 2, 3, 4, okay? So that's one mistake you don't want to make, okay? The presence of these exponents, okay, makes a big difference, right? So these are called the multiplicities, okay? It tells us how many of each factor there actually are, okay? Let's take a look. All right, let's set each factor equal to 0, right? So we're going to set each, oh yeah, I should write that down, right? These are called the factors, so we want to get the zeros, okay? Let's set each factor equal to 0, so negative x is equal to 0, right? X plus 5 is equal to 0, x plus 2 is equal to 0, and x minus 3 is equal to 0. So of course, x is just equal to 0, x is equal to negative 5, x is equal to negative 2 here, and x is equal to positive 3. But once again, right, what does the presence of this squared here do to the multiplicities? Okay, so if you think about it, well, yeah, if I solve each of these, right, shouldn't there be 2 x equals negative 5s? Okay, so the way we deal with that is we call this a multiplicity. Okay, so we use the m to stand for the multiplicity. The multiplicity here is 2. And what this tells us is that in the original polynomial, there were actually 2 x plus 5 factors. Okay, so we don't need to list out x equals negative 5 twice. Okay, we say the m, or the multiplicity in this case, is 2. So similarly, right, we'll say that this multiplicity is 2. Now, of course, these multiplicities are just 1. Notice what happens when you add the multiplicities together, right? 1 plus 2 plus 2 plus 1, that total equals 6, which should match up, right? Because we know that the degree of this polynomial is 6. Okay? So let's summarize this, okay? There are 4 factors, okay? There are 4 factors, but the degree is 6, right? So the multiplicities total should add up to 6.